Welcome to Two Projects. In this video, we are going to explain the project Block Access Control in Wireless Blockchain Network Design, Modeling and Analysis. Introduction. The primary goal of this project is to improve the security and reliability of wireless sensor networks. Traditional wireless sensor networks have inherent vulnerabilities in centralized servers, making them susceptible to security breaches and data loss risks. Centralized data storage poses a single point of failure, while limited scalability can lead to performance bottlenecks impacting network reliability and efficiency. To address these challenges, the project focuses on integrating blockchain technology into wireless local area networks, wireless LANs. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And we employ light nodes, full nodes and access points while implementing access control strategies such as BAC1, BAC2, BAC3 and BAC4 to improve data transmission reliability. Additionally, smart contracts on the Ethereum blockchain guarantee data integrity. Objective of the project. So, by integrating decentralized blockchain technology into wireless local area networks, wireless LANs, the project aims to distribute data storage across multiple network nodes. This approach enhances data availability and redundancy, reducing the risk of data loss due to server failures or attacks. Each node in the network becomes a part of the data storage solution, ensuring data can be retrieved from multiple sources. And to ensure smooth and reliable data transmission in scenarios where multiple nodes simultaneously send data, the project introduces 4 access control strategies. These strategies define rules and conditions that prioritize when and how data can be transmitted. This prevents data corruption and forking issues, maintaining data integrity within the network. The project categorizes network nodes into distinct roles: light nodes, LNs, full nodes, FNs, access points, APs. Light nodes are responsible for data sensing, collecting information from the environment. FNs process and mine the collected data into blockchain storage blocks, enhancing data security and reliability. And APs serve as central nodes responsible for storing and distributing blockchain data to ensure its availability across the network. And by leveraging the Ethereum blockchain and Solidity program language, the project deploys a smart contract. This contract acts as a bridge between the network and the blockchain, ensuring the integrity and immutability of sensor data. It enforces rules and conditions for storing and retrieving data, enhancing trust in the system. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is Setup Wireless LAN Network. This module is responsible for configuring and establishing the wireless local area network for the project. It generates the wireless LAN network, including the placement of nodes and their roles, such as light nodes, full nodes and access points. It sets up each node's characteristics, including their communication capabilities, responsibilities and initial parameters. It defines the layout and connectivity of the network, specifying how data will flow between nodes. The second module is Start Block Access Wireless LAN Simulation. This module initiates the simulation of the wireless blockchain network, enabling data transmission and the application of access control strategies. Light nodes begin sensing data from their surroundings. This data is typically generated randomly in a simulation scenario. Light nodes send the sensed data to the designated full node for processing and blockchain mining. The chosen access control strategy is applied to regulate data transmission. This ensures that only one node can transmit data at a time, preventing conflicts and forking issues. FNs create blockchain storage blocks by mining the received data, and these blocks are eventually sent to the access point for storage. The third module is Transaction Throughput Graph. This module is responsible for calculating and visualizing the throughput of data transactions within the wireless blockchain network. This module tracks the number of data transactions and the successful transmission. It computes the throughput, which refers to the amount of data transmitted successfully over time. The results are graphically represented, typically using line graphs. Each line on the graph represents a different access control strategy, allowing for performance comparison. And the last module is Stop Simulation. This module is designed to halt the ongoing simulation, bringing the network activity to a stop. When activated, this module terminates the data sensing, transmission, and access control processes. Blockchain integration. So, instead of relying on a centralized server, blockchain distributes data storage across multiple nodes. This approach ensures redundancy and fault tolerance. Data is replicated across the network, reducing the risk of data loss in case of node failures or network issues. And FNs receive data from light nodes and process it into blocks suitable for blockchain storage. This mining process involves validating and timestamping data, adding it to the blockchain, and ensuring its security and immutability. A unique hash code is generated for each data block, serving as a digital fingerprint. POW verification, that is, proof of work verification, ensures the validity of the data block before it is added to the blockchain. This verification process safeguards against data tampering and maintains the integrity of stored information. Data blocks created by FNs are transmitted to the AP for storage. The AP maintains a record of these blocks in the blockchain, making the data available for other FNs to download and verify. This distributed storage approach ensures data availability across the network. Access control strategies define rules and conditions for data transmission. They prevent issues such as data forking, where multiple nodes simultaneously send conflicting data. By regulating when and how data is transmitted, these strategies enhance the reliability and consistency of data within the network. And a Solidity smart contract is implemented on the Ethereum blockchain to interact with the wireless sensor network. This smart contract serves as a bridge between the network and the blockchain. It enforces rules for data integrity and immutability, ensuring that sensor data stored on the blockchain remains secure and unaltered. The contract enhances trust and reliability in the network. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is Hello ETH folder. In this folder I have a node modules folder. This folder consists of dependencies or modules needed for the project. Now open .bin folder. This folder often contains executable scripts related to the project's dependencies. So here we can see a run blockchain.bat file. Double click on it to start the blockchain. So this script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at the local host and port. This address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. So Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They're deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. So this is the contract address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. So to execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this. This is Python main code file and this is block access wireless LAN SQL file. This file consists of Solidity code and it handles data structures, functions and events with modifiers for validation. And this is run wireless LAN.bat file. Instead of executing the project through command line interface, we have created these Windows BAT files. So now double click on it. This graphical user interface will be open. With this, we're interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Setup Wireless LAN Network button to set up network. So here we can see all blue color circles are considered as light nodes which send data to full nodes, and the nodes which are nearer to AP, that is red color node, are called as full nodes. So these are all full nodes, and red color circle is called as access point. And all light nodes send data to full nodes and full nodes send data to access point. Now click on Start Block Access Wireless LAN Simulation button to start sending data to access point. So here we can see each blue light node will be randomly selected as source, and it will send some random data and send to green color full node, and full node sends the data to access point. And here we can see data sending via a black color line. And if one node is sending data, then other nodes will wait and continue only after first node completes. And this simulation will run in infinite loop, and to stop simulation we have to click on Stop Simulation button. So I'm clicking on Stop Simulation button, and in text area we can see which node is sending which data and which node is selected as full node. Now click on Transaction Throughput Graph button. So in this graph, on x-axis I have number of transactions and on y-axis I have throughput. So throughput refers to amount of data sent from start to end, and blue line represents BAC1 strategy throughput, and similarly different lines represent different strategy throughputs. In all techniques, BAC1 got high throughput. Now close this graph. So the conclusion here is the integration of blockchain technology strengthens data security by addressing centralized server vulnerabilities, safeguarding data integrity and offering fault tolerance. Blockchain's unique hash code and proof of work verification provide robust guarantees of data integrity and resistance to tampering. This makes it an optimal choice for safeguarding critical data in various applications. The utilization of access control strategies efficiently manage data transmission, eliminating the risk of forking issues in multi-node networks. Through the implementation of smart contracts on the Ethereum platform, the project ensures secure and immutable data storage, reinforcing the reliability of sensor data. And the successful integration of blockchain demonstrates its practical potential, and it renders wireless sensor networks more resilient, secure, and suitable for critical monitoring applications, underlining its value in enhancing network performance and data protection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.